Hello everyone. Today I will discuss about radiation. What is radiation? Radiation is defined as energy that travels through the space or matter in the form of particle or wave. It can be produced in one of two ways: by radioactive decay of an unstable atom or by the interaction of particle with matter. Some attributes of the radioactive decay are that it is a spontaneous and random, and the type of radiation emitted depends on the specific radionuclide. Radiation emission as the result of an interaction, on the other hand, depends on both the incoming particle and the material it hits, and is theoretically predictable if enough information is known. It is described by its type and energy. The type of radiation fall into two main categories. First is called particulate radiation and second is called electromagnetic radiation, commonly known as the EM radiation. So what is particulate radiation? Particulate radiation consists of particles that have the mass and energy and may or may not have an electric charge. For example, alpha particle, protons, beta, and neutrons. So these are the example of the particulate radiation. Second is the electromagnetic radiation. On the other hand, it consists of the photons that have energy, but there is no mass or charge. A photon, it is described by a quantum theory, it's a particle or quantum that contains a discrete quantity of the electromagnetic energy which travels at the speed of light or 3 into 10 to the power 8 meters per second. A photon is sometimes also known as packet of light. Visible light, ultraviolet light, X-ray, and gamma ray all are the photons. Radio waves, visible light, X-ray, and gamma ray are the different types of the electromagnetic radiation. Electromagnetic radiation is unaffected by either electric or magnetic field and has a constant speed in a given medium. Although electromagnetic radiation propagates through the matter, it does not require matter for its propagation. In matter such as air, water, or glass, its speed is a function of the transport characteristics of the medium. Electromagnetic radiation travels in the straight line, however, its trajectory can be altered by interaction with the matter. The interaction of electromagnetic radiation can occur by scattering, absorption of the radiation, or at very higher energy transformation into the particle or particulate radiation. Electromagnetic radiation is commonly characterized by the wavelength, frequency, and energy per photon. For convenient reference, the electromagnetic spectrum is divided into categories including the radio spectrum that include the transmission from familiar technology such as the AM, FM, and TV broadcasting, cellular and cordless telephone system, as well as other wireless communications technologies. Second is the infrared radiation. It includes radiant heat, and next is the visible, ultraviolet, and X-ray as well as gamma ray region. Several forms of electromagnetic radiation are used in the diagnostic imaging. Gamma rays emitted by the nuclei of radioactive atoms are used to image the distribution of radiopharmaceuticals. X-ray produced outside the nuclei of atoms are used in the radiography, fluoroscopy, and computed tomography. Visible light is produced when X-ray or gamma ray interact with the various scintillators in the detectors used in the several imaging modalities and is also used to display the images. Radio frequency electromagnetic radiation near the FM frequency region is used as an excitation and reception of the signal for the magnetic resonance imaging, commonly known as the MRI. Because the speed of electromagnetic radiation is constant in a given medium, its frequency and wavelength are inversely proportional. Wavelengths of the X-ray and gamma ray are typically measured in the fraction of nanometer. The discrete packet of electromagnetic energy are called photons. The energy of photons are commonly expressed in the electron volt, that is denoted by small e and capital P. 1 electron volt is defined as the energy acquired by an electron as it traverses an electrical potential difference of 1 volt in a vacuum. Next is the ionizing radiation. An atom or molecule that has lost or gained one or more electrons has a net electrical charge and is called an ion. Some but not all electromagnetic radiation and particulate radiation can cause ionization. In general, photons of the higher frequency than far UV region of the spectrum, that is wavelength greater than 200 nanometer, have the sufficient energy per photon to remove bound electron from the atomic cell, thereby producing the ionized atom and molecules. Radiation in this portion of the spectrum is called ionizing radiation. For example, X-ray and gamma ray is the example of ionizing radiation. Next is the non-ionizing radiation. Electromagnetic radiation with the photon energy in and below the UV region, for example, visible, infrared, terahertz, microwave, and radio waves, is known as the non-ionizing radiation that cannot form the ions. The threshold energy for the ionizing depends on the type and state of the matter. The minimum energy necessary to remove an electron, referred to as the ionization energy from the calcium, glucose, and liquid water, are 6.1, 8.1, and 11.2 electron volt respectively. As water is the most abundant molecular target for the radiation interaction in the body, a particle radiobiological demarcation between the ionizing and non-ionizing electromagnetic radiation is approximately 11 electron volt. While 11 electron volt is the lowest photon energy capable of the producing ionization in the water, in a random set of ionization event evoked in a medium by ionization radiation, the average energy expended per ion pair is larger than the minimum ionization energy. Particulate radiation such as high-speed electrons and alpha particles can also cause ionization. Thank you.